Hello, welcome to our first video this second semester on lesson 6.3 in geometry. One of the key ideas that I want you to keep in mind is that anytime we're working with similarity in chapter 6, you want to think about how the shape is proportional. Okay, which sides match up? Okay, what can you correspond with each other? And if anything is similar, okay, it's going to have a scale factor, and we want to really work with identifying the scale factors. We're going to kind of extend the lesson that we were working with in 6.6 with proportionality and apply it truly to similar polygons. So let's go ahead and open up our notes so we can take a look. There it is. All right, we'll make this a little bit bigger so that we can see. All right, so today we're going to take some time to discuss our similar polygons. Now, keep in mind that what we are going to do is focus on writing that scale factor and solving for missing values between our figures. But we need to do a little bit of a review. Last semester, we really focused on congruent shapes, and we're going to use triangles here. And now we're going to work with similarity. Okay, the key idea, if you are looking at something that is similar, you are going to have the same shape, just a different size. And that different size is that scale factor. Okay, so we just want to kind of keep that in mind. And then notation-wise, here's our similar symbol. Now you're going to notice it kind of looks like a congruent symbol. Congruent, we just put a little tilde with the equal sign. So then it becomes everything's equal. So this is same shape. And then when you have same shape, same size, okay, it becomes congruent. All right, so let's look at the triangles that I have here. We're going to base everything or compare everything to triangle ABC in this figure. Well, when we look at triangle DEF, okay, we're going to look at these two triangles being congruent. So my congruency statement would be triangle ABC is congruent to triangle DEF. And again, always make sure that you have the order correct if you're writing out that congruency statement. Okay, angle should match up. Angle A is congruent with angle D. You can see that there. Angle B with E, and angle C with F. Okay, angles have to be congruent to create the same shape. Now, if our triangles were congruent, all our sides also had to be congruent. So if I were going to match up the corresponding sides, we would say that side AC would have been congruent with DF, and side AB would be congruent with DE, and side CB would be congruent with FE. And when you write out these congruency statements for your sides, they should also match up with the order that it was written in the congruency statement. So for instance, side AB is the first two letters here, should be congruent with the first two letters here, side DE, so that everything's aligning, right, and written in the correct order. Now, when you have similarity, what you should notice right away is we still have this scalene right triangle shape. It's the same shape that was given in the previous two triangles. It's just a different size. Okay, we went from a length of 6 down to a length of 3. We cut that in half. Okay, we went from 10 down to 5. We went from 8 down to 4. So everything's been cut in half. That's that scale factor of 1/2 in this case. So the first thing I want to be able to do is write that similarity statement. So we would say triangle ABC, which was my original one here, is going to be similar to triangle GHI. And then we're going to look again at the angles. Remember, angles are creating shape, and it has to be the same shape. So the angles have to be congruent. So again, angle A with angle G, okay, angle B with angle H, and angle C with angle I. Okay, those are still congruent. However, the sides can't be congruent because the size changed. So we want to say that all corresponding sides are proportional. So what we're going to do if it's proportional is set up those ratios. So we know that side AC, okay, corresponds with side GI in this similar triangle. So there would be my ratio. Okay, it would give us a ratio of 6 to 3. Okay, now that's going to be equal with any other ratio between my corresponding sides because we have proportionality. So I can also take side AB and compare that to side GH. Or compare side CB to side IH. And you'll notice that they end up with the same ratio. Okay, so here, for instance, side CB was 8 units compared to side IH, which was 4. But again, that would reduce to 2 over 1. Okay, or here, 2 over 1. So that same scale factor. So your scale factor is going to be that value, okay, from a ratio, okay, made by corresponding sides. So again, if I look at those corresponding sides that I just set up, they set up ratios of 6 over 3, 8 over 4, or 10 over 5. Those all reduce to 2 over 1. Okay, so 2 over 1 there is considered the scale factor. And remember, we used that variable K for scale factor last semester, and we will continue to do that. So that should tell me that that first triangle here is 2 times the size of the second. Okay, so let's look at a few more pieces of information here. So by definition, if all angles are congruent and all side lengths are proportional, then the polygons are similar. Okay, if all angles are congruent, but all sides reduce to the same scale factor, okay, then the polygons are similar. We kind of have some extra spaces in there. Okay, so in this case, what this is saying here is that if you have the same scale factor, okay, between the scale factors are all equal, okay, then you do have proportionality, okay, meaning your shapes will then be similar. Now, you want to be very careful of how you compare the sides, that you always have corresponding sides set up, okay, and you want to make sure you're doing those in an order to make sure you don't mess anything up. So you always want to kind of organize that from the smallest length to the largest. So you kind of see this notation up here. So we're going to determine if these two rectangles are similar. So shape 1, I'm going to use the outer, okay, rectangle here. So the smallest side I have on this rectangle is 16. So I have 2 sides of 16 since that's a rectangle. And then the largest side is 24. Now, if I'm setting up those scale factors, I'm going to see that on my smaller rectangle, my smallest sides are 4, and my largest sides are 6. Okay, these scale factors here all reduce to 4 over 1. So if I was going to determine if these were similar, I need to see that angles are all congruent. Well, if it's a rectangle, all my angles, and they're all marked with right angles, all marked with right angles. So all angles are congruent. So that created that same shape. And then if my scale factors are all equal, then I know my sides are all proportional. So if angles are congruent and sides are proportional, then our shape is similar. So we would be writing a similarity statement. So we would want to say my first shape, and just kind of go in order there, W, X, Y, Z, would then be similar to, and then go in the same order, set up those corresponding angles, D, A, B, C, okay, in that case. You could have a little parallelogram symbol in front because a rectangle is a parallelogram in this case. But as we get more sides to our polygons, just list the vertices in order there to identify your shape. All right, so let's look at a triangle problem in here. And again, you're gonna see, and you should always kind of look to see, you know, do you have a rotation, a reflection, okay, or a translation there. So you're matching up the correct angles. But another good method with similarity is just to make sure that you're looking at those values in order, because you always want to be matching up the smallest side, the medium sides, and then the largest side of these scalene triangles here. So if I take my first triangle, the smallest side here was 28. That will have to correspond with the smallest side in my second triangle, which is 20. Now, if we look at the medium size, okay, the middle length here was 35, which corresponds to the middle length here of 25. And then the largest sides, 42 and 30. Okay, now your job with these to recognize whether these scale factors are all equal is to reduce those fractions. Keep in mind you can reduce fractions by just entering, I guess I should enter it the other way, entering the ratio in your calculator and then converting that to a fraction. It will automatically reduce that if you happen to have a graphing calculator or you have a fraction menu in yours. Okay, or you could just see, like here, I can see those both divide by 5, so that would give me 7 over 5. Okay, 42 divided by 30, we'll just do that one more time. Okay, 7 over 5. Okay, all scale factors are equal here. And if all angles I could match up as being congruent. So we can see that angle D was congruent to angle X. Angle Y was congruent to F, and my third angles theorem would tell me that angle E then has to be congruent to angle W, because this third angle would have to have that same measurement. So then angles congruent and sides proportional. Okay, we'll make my shapes similar. So triangle D, E, F will be similar to, and then again, match up your angles. So angle D corresponded with angle X, angle E with W, and then angle F with Y. Okay, and then just your similar sign in there, not congruent because they're not the same size. Okay, just similar. Okay, and then you can kind of see here, it's starting out with telling us we have similar triangles. So there's your similarity statement. And now we want to try to find some values in here. So write a proportion statement for these similar polygons, okay, which is located right here. Now, if we wanted to solve, okay, for y, which is that side length, okay, right there, we'd set up a proportion. So I can see I know side 9, okay, which was side AC. So that should correspond with OD, okay, which had a side length over here of 3. And then we had 9y minus 1, which corresponds to a side length of 5 on the other triangle. Now, again, with any proportion, we can always cross multiply, but be careful with those binomials because you will need to distribute. So 3 times 9y minus 1 equals 45. So 27y minus 3 is 45. 27y equals 48. So y equals 48 divided by 27. Okay, that would reduce to 16 ninths, okay, or approximately 1.78. And then you could kind of see how that would work in here. If we plugged in the 16 ninths, we would get then the 9s to cancel. So this would just be here 16 minus 1, which is 15 over 5, which would be 3. Okay, so then we can see, whoops, how that would be equal if we were working that out. Now, if we were asked to solve for x, x is an angle. Okay, so let's look at angle T. We know angle T will have to align with angle G. And angle G was 45 degrees. Angles are congruent, so just make the two angles equal to each other. And then x will be equal to 9. Okay, so kind of if you're solving for a side length, you're writing a proportion. You're solving for an angle, you're making those two angles equal. Okay, so just some key ideas as you look at those. Now, as we extend this idea of proportionality, what we want to keep in mind is that proportionality can be set up in similar triangles between any types of lengths. So we have some special types of lengths that can be drawn or set up, okay, in our triangles that we kind of use throughout the year. Okay, one is an altitude. You're actually drawing an altitude on a diagram. It's going to go from a vertex to the opposite side at 90 degrees. Now, you often just recognize that within a figure as the height of the triangle. A median is going to go from a vertex to the midpoint of the opposite side. An angle bisector is going to cut an angle in half, and we looked at that in our last lesson. And then keep in mind, perimeter is the distance around a figure. That's always found by taking the sum of the sides. But if it is a distance around, it is a length. So it will have proportionality features that you can set up within a proportion. So kind of some key ideas to keep in mind. So for instance here, these triangles are similar. So the side lengths are all proportional, but the altitudes in here should also be proportional. So if we were going to look at that as far as this example here in number 1, okay, we can say that in my first little triangle right here, okay, TPR, we have an altitude of A and a side length of my triangle of 12. Now that would correspond in my second triangle, an altitude of 20 and a side length of 16. So if I wanted to solve for this altitude, I could then cross multiply from this proportion. So 16a equals 240. We can divide that by 16, and we get an altitude in that first triangle of 15. Okay, in the second one, we could solve for the perimeter of this larger triangle by solving for the side lengths of each side of this larger triangle and then adding those together. But we do have a shortcut here because we have two corresponding sides. Okay, side ML, okay, will be similar to side PQ. So that will set up a ratio here, okay, of 9 to 12. Well, then we can find the perimeter, okay, of that first triangle. So 9 plus 15 plus 21. And it has a perimeter of 45, okay, if we go around this shape. And I could compare that to the perimeter of this triangle over here, okay, and we'll use the proportion to go ahead and solve that. Okay, well then I can just go ahead and cross multiply this proportion. So 12 times 45 gives us a value of 540. We'll divide that by 9, and we get 60. So then this would have to have a perimeter of 60 units. Again, perimeters will be proportional because those are lengths. So you could set them up in the proportion to solve that. Okay, so then again, if I was looking, my scale factor was 9 to 12. Okay, or you could have seen that that reduces to 3/4. Okay, either way, that could have been used. And then the larger perimeter was 60. Okay, so just kind of some special topics there to kind of add into that similarity lesson. But again, your key ideas throughout this is that if your figures are going to be similar, they're going to be the exact same shape. Same shape can only be created by congruent angles. And then it is a different size, but that size has to be proportional, meaning the scale factors would always need to be equal. Okay, so just kind of careful there with those. If you have any questions on lesson 6.3, make sure to bring them to your Thursday, Friday lesson, and then we will get those answered. Okay, good luck with your Wednesday homework.